ISI surveys, and other anthropometric research projects. His leadership in overseeing surveys has included both traditional tape and caliper measurements as well as 3D surface scan. He has worked on anthropometric accommodation for an array of products, including automotive interiors, military vehicles interiors, head-mounted products, respirators, automotive lumbar supports, infrared car seats, and a variety of personal protective equipment, such as helmets, gloves, or chemical protective garments. Based on this super broad experience, he's going to give the talk Anthropometric Surveys, Plan Before You Measure. Before starting, I have a remark related to the webinar platform. There is a section for the Q&A. The access button is in the bottom part of the screen, just together with the chat. So please, you can write there your questions. And without further delay, Dr. Bruce, the floor is yours.
Thank you so much, Sandra. I guess, I don't know if you can see me or not. I can see Sandra still.
Yes, we can see you. You should
Oh,
share
okay.
the screen.
Okay, very good. Fine. Hi, everybody. And as Sandra said, good morning, good afternoon, and good evening, as the case may be. We're delighted that you're able to join us today. We're going to talk about anthropometric surveys. And yeah. Okay. Yeah, so this is just a little bit about me, which you've already heard. So, I mean, why do we want to collect more anthropometric data? People ask me this, and they say reasonably so. I mean, we've been measuring people for, 150 years or 200 years, and surely we've measured everybody we need to measure, and can't we just remine the data that we already have? And certainly we can do that. But there are some reasons that you might want to collect some additional data. So, for example, if you have a new population that's never been measured before, and I'm not thinking, Aboriginal groups on uninhabited islands somewhere, but I'm thinking about, we did a project with school bus drivers. Well, that was a population that had never been measured before. We did a project with truck drivers and various occupational subgroups that may or may not be anthropometrically representative of the population as a whole. Sometimes we want to measure those because it's a relatively new group. Similarly, on a national level, some countries, I think of Korea, for example, does anthropometric surveys quite regularly, and it's a government project, and it just goes ahead, and it's terrific. Other countries do surveys relatively rarely. Some countries have never done them at all. So those countries may wish to do a national survey, for the first time. Another reason you might do some surveys is monitoring. If you've measured your population, let's say 10 years ago, are they the same? If you are designing products that are going to be used over a long period of time, you need to understand the change that's taking place, if any, over a time period. And so you may want to do a periodic, every 10 years you want to measure perhaps, or some interval like that. And then the third general reason that you might do some new data collection is if you need some dimensions that have never been measured before for new sorts of products. We've done some work in the not too recent past about wrist size and shape, because companies were making all kinds of fancy
Bruce, can you hear us? I'm assuming people can hear me. Oh, there we go, Bruce. You're
Yes,
back.
Yes,
I can.
I think
Sorry,
I
the screen.
left.
There you go,
Okay,
the
are we,
screen.
yeah, are we still on my screen sharing?
Yes, you're back now.
Okay, great, thank you.
Not on the screen sharing. You'll just have to put the screen sharing back on again.
Gotcha, okay.
There we go. We're back
Okay,
up. We're back
good,
up.
thank you, thank you. I should say I live in a small town in rural Ohio, and sometimes our internet is not as good as it might be, so I apologize for that.
You might just want to put it in presenter mode.
Yep, there it is. Yep, thank you. We did an interesting project for a company making robotic surgery equipment, because the surgeon looks into a device and rests her forehead on a little part of the device to stabilize her head. And this company wanted to know about forehead size and shape. Well, that was something that had never been measured before, so we needed to collect some new measurements about that. So anytime you have new products that require specific dimensions, you may need to collect some new data. So that's a reason to do that. So we've decided we need to take some measurements, do a survey. So what dimensions are we going to measure? There are several things to think about in that regard. One, certainly if we're doing a periodic survey after every 5 or 10 years, we want to make sure that we're measuring some dimensions that we've measured in the past, so we can have compatibility over time. Yeah, I have a particular fondness in my heart for ISO standards, and there is a ISO standard series on anthropometric measurements that has input from scientists all around the world. And so I strongly encourage everybody to use measurements that are on the ISO 7250 list, because that allows us to compare between country A and country B, which is often useful just from a purely scientific point of view, but it's also useful from a product design point of view. If I'm selling a product in England, will the same product work in South Africa? Well, I don't know. I need to compare the data for those two countries. And then finally, if we're doing 3D scanning, which often we're doing these days, we need to decide, are we going to take some dimensions from the scans, or are we going to measure people directly with tape and calipers? Those are decisions that need to be made. So the choosing of dimensions is actually kind of complex. As I mentioned, we want to harmonize with international standards. We want to be compatible with previous surveys, allowing us to do a longitudinal analysis. I recommend and strongly encourage alignment with the ISO dimension list. And all of that gets us consistent data across surveys and across time. And it increases the validity of the data, allowing us to make sure that we can use the data with confidence, which is ideally what we want to do. Okay, so I mentioned 3D scanning. It's always a decision, yes or no, whether to do that. There are a number of considerations on that decision. Certainly, cost is one. High quality scanners are not inexpensive. On the other hand, hiring survey measurers is not inexpensive either. There are some advantages of 3D scans. You can scan today and collect data tomorrow. It's especially helpful, like in the case of the foreheads for the robotic surgery. Even though you didn't have that question when you collected the data, you can go back afterwards and say, oh, now I have a question about foreheads. I can go to my previously scanned data and extract that. So that's a huge advantage to scans, is that you can collect data in the future that you don't even know you need today. Also, the scans can, it's not always the case, but can make it quicker for the survey participant. If you're being measured for, 100 dimensions with a tape and caliper, it takes a fair amount of time. Scans are typically done fairly quickly. There may be several poses, but still, that is quicker for the participant. So that's useful as well. Some disadvantages to scans, I think, have to do with if we're looking at a volunteer survey, participant volunteers, see the gentleman on the left who looks terrific, but we don't all look that way. And there is, I think, some risk that on a scanning survey, people who don't feel like they look very good, don't feel like they're happy with their body image, may choose not to volunteer for the survey. And in that case, then you have kind of a sample bias with, some significant portion of the population that's just not volunteering. So that is kind of a downside, but, that possibly can be mitigated with recruiting strategies. But certainly, if you're using scan data to replace tape and caliper measures, you want to make sure that you're getting accurate data out of the scan. And of course, the scan manufacturers, because they are selling a product and they love their product, will tell you that they're highly accurate and so on and so on. But I always believe that your gold standard is really a highly trained and experienced measurer. And so whatever the scanner company tells you, I would myself validate with live human participants that actually you can get the accurate data out of the scan that you think you're getting out of the scan. So, so we have our definitions, our measurements chosen. If we have traditional measurements that we've used before, they don't need to be validated. But if we have some new dimensions, and I'm thinking about, my forehead example or interior ear dimensions or things like that, if we're defining a new dimension, you need to essentially test that definition. And how I do that is I bring in, I have a draft definition written down, maybe with a picture or two, and I bring in 3 or 4 or 5 people and have them just read that definition and look at the picture and try to take that measurement or try to find that landmark. And so I'm, in that case, not testing the population, I'm testing the definition to see if it is clear to any reader. Because I'm a big proponent of hands-on training, but at the end of the day, sometimes, people are just going to see your written definition and just go out and try to do that. So you want to make sure that the definition itself is so clear and unambiguous that anybody could read it and understand how to do it. And as I said, that goes for dimensions as well as landmarks, which we use, as you all know, the beginning and end point of dimensions. And then if we are using new equipment that we've never used before, and that could be a scanner, but it could be any other sort of measuring equipment, that needs to be validated also. And you make sure you get the same answer twice or 3 times, hopefully, and make sure it's reliable and that you're getting the kind of data that you think you're getting. So how do we document? I document at least 3 ways, and I'm going to propose to you today a 4th way. But certainly we have a written description of the landmark and or the dimension, and then visual documentation of it. I like both a photograph and a line drawing. And the same thing is true of the scanning procedures. If there is, I mean, the only way you're going to get good data out of a scan is if you have a standardized posture for the participant, or postures if you're doing more than one scan. And those postures need to be documented, again, with descriptions and illustrations, because if you don't have the right posture, you will get bad data. So here's an example. I would have on the left, this is just a chromion, but I would have, written description of it with a little line drawing. I would then have a photograph with a live human participant, and I like these sort of 3D-ish sketches. This particular one on the right is made with Poser, but there are any number of those now. But what I would like to see, honestly, and I have never seen this happen, but I think it would be truly useful, since all of our documentation now is going to be online anyway, why not have some sort of an avatar where you could see the skeleton inside it and have the user be able to rotate that image, because what we're looking at here, and this is optimized for a printed description, I can just see one side of that point. But I would love to be able to turn that around to look at it from the front or the top or the back. So I think, and technologically, that is all possible at this point, but I don't know that anyone has done that for an anthropometric documentation, but I would hope that somebody on this call will take that and do it. I think it'd be terrific. So, all right, so we have our dimension list. Our dimensions have been validated. And now we have to think about observer error. So it is the case that humans make errors, number one. And number two, when you're measuring the human body, which is a living and breathing thing, and we are not rigid, and even if we're standing perfectly still, we're actually not standing perfectly still, we're moving around a little bit. And so it's almost impossible to take the same measurement 2 or 3 times to get exactly the same value. That is just the way it is with humans. If we were measuring a steel block, it would be a different situation. But when the thing you're measuring is squishy and moving, there is some measurement error that will occur. So what we need to do is find out ways to minimize that error, but also find ways to track it and decide how much is too much, how much error can we live with, how much error can we not live with. So, so there are some steps for that. I would review some previous allowable errors from earlier studies. If the dimensions are the same, you might be able to use them. But if you've got some new dimensions, you're going to need some new allowable errors. And how we do that, it's time consuming, but I consider it really important. We bring in a bunch of participants and we bring in 3 or 4 experienced measurers and have all the measurers, measure all the participants, and then compare the data and see, how reliable experienced measurers are, and use that to determine what's a reasonable allowable error, because you don't want to have standards that are so tight that no one can meet them. On the other hand, you don't want standards that are so loose that you have mess in your data. So I would strongly recommend that you could develop allowable error tests for any new dimensions. And then if you've got revised measurements that you took 10 years ago, and for whatever reason you need to change it, well, then you need to review that allowable error as well as revalidate that dimension. And once you do that, then you establish your acceptable tolerance ranges. So, for stature, it might be plus or minus 5 millimeters. For waist circumference, it might be plus or minus 8 millimeters, or whatever the numbers are. But, it also, the other thing that's important there is, what are these dimensions going to be used for? A waist circumference, for example, is used in clothing. And, well, clothing, you want it to fit. It doesn't have to fit perfectly. But if you're taking measurements of the face because you're going to make a chemical protective respirator, 6 millimeters is way too much. The thing is going to leak. So for something around the face, if that's one of the goals of your survey, then your allowable error for those dimensions needs to be quite small. So there's no rule of thumb. Allowable error should be 4 millimeters. It really depends on the dimension, and it depends on what you're going to do with the data when you're done. But it's critical to have allowable errors prior to data collection. And also, actually, it's useful even after data collection, because if you're comparing subgroups, my population subgroup A versus subgroup B, and I see, in this dimension they're 3 millimeters different on the mean. Well, okay, but if I look and discover that the observer error is 6 millimeters, then really it turns out subgroup A and subgroup B are not that different because it's within the allowable error. Okay, so now we've figured out what we're going to measure and how we're going to measure it, how we're going to determine if it's valid. So the next question is, who are we going to measure? So in the case of our, school bus driver survey, we were just measuring school bus drivers. But in national surveys, where you obviously can't measure everybody, you need to make sure that you're measuring some kind of a representative sample. So in the United States, for example, because we have hundreds of years ago history of slavery, and folks brought against their will from Africa mostly, and other folks that have come to the US from Europe and Asia and so on. And because those subgroups are different anthropometrically, we need to make sure that they're all included appropriately in our sampling strategy. Other countries, for example, the Netherlands, because of their history hundreds of years ago, they have anthropometric differences between the North and the South. And in Malaysia, for example, in their history, they have 3 different kind of ethnic groups that make up their population. So there's no simple answer, but depending on what population you're trying to capture, you need to know something about the internal variability of that population to make sure that you capture it in your sampling strategy. The next thing is, I'm calling it a sample type, but basically, are you trying to just do a snapshot of your population? Okay, that's one approach. Are you trying to have a sample that allows you to do comparison analyses on subgroups within your population? Well, that's a different type of sample strategy? Are you trying to predict what your population is going to look like in the future, which is important, for example, in military hardware. If you're designing a tank or a jet fighter, it takes 5 or 10 years to design it, and then it has a 20 or 30-year lifespan. So the designer of that jet fighter cockpit wants to know, well, what's my pilot population going to look like in 30 years? Well, so you sample differently to answer that question. So again, depending on what is the purpose of your survey, will determine what kind of sample you want to have. And then the third piece about sampling strategy is how many. So are we going to measure 3 people or 300,000 people? And obviously the cost is a huge, that question affects cost in a huge way. But, you need to you need to measure enough people to make sure you're capturing the variability that you want to capture. So, all right, so I introduced these already. A snapshot is a point in time for a current characteristics of your population. That same kind of parameterization can be used if you're doing a predictive model, what's going to happen 30 years from now. So this is one approach that we use sometimes in the United States, because we have different ethnic groups that have different anthropometric characteristics. We typically also sample by age, because our bodies change as we get older, and not just in the growth period, which where the change is dramatic, but certainly as we age. I'm sorry to report that our waist gets bigger, our chest gets smaller, our stature shrinks, and various things. So you can't capture your population if you're only measuring college students or something like that. So we want to make sure that we capture the whole age range of interest. We want to make sure that we capture the racial subgroups of interest. And again, if you were measuring in Malaysia, there would be different groups here. If you were measuring in the Netherlands, there would be different groups here. But the point is, you want to make sure that you're explicitly capturing the internal variability in the population of interest. So that said, how many do we want to do? So this is from one of the ISO standards on anthropometric databases, which I highly commend to you, ISO 15535. This is a formula for calculating the sample size with confidence at the mean. So n is the sample size we're after. Let me see if I have a little pointer here. I think I have a pointer. Anyway, n is what we're trying to calculate. S refers to the standard deviation. Basically, it's a measure of variability. So, if everybody in India were the same size, we'd only have to measure one person in India, but of course they're not. So the more variable the dimension is, the more people we have to measure. The Z term refers to the level of confidence. In other words, how certain do we want to be that we have the right answer? And finally, at the bottom, C refers to the precision. So do we want to know our estimate to the nearest 2 millimeters, the nearest centimeter, the nearest 5 centimeters? So all of that influences how many people we have to measure. So here is I'm stuck now. There it is. Oh, my little thing's stuck on there. Sorry. Anyway, this is an example. So our standard deviation is 81.8. So I put that here where the S was. I want to be 95% confident. So the Z-score associated with that is 1.96. So I put that in here. I want to be in this particular case, and this is arbitrary, but it can be based on how I'm going to use the data. In this case of waist circumference, I want to be within 1.5% or 12 millimeters of the true value. So I pop that in and I do the little math and I come up with 179. So what that number tells me is if I measure 179 people, I am 95% confident that my population mean of my sample is within 1.5% of my true population mean. Now, and that is good, but we typically don't do our designs based on the mean value. We typically do designs based on some distant values. So I wish I knew how to get rid of that stuff. Oh, eraser. Look at that. So in this case, we have the same starting points, Z, S, and C, but we have a correction factor to put us at the tails of the distribution. So using the same example, I put the same numbers in, 1.96, 81.8, and 12, and I get 420. So what that tells us is, if I measure 420 people, I'm 95% confident that my 5th and 95th percentile values are within 1.5% of the true population 5th and 95th percentile values. And so I hope it makes more sense that you would have to measure more people to make sure that you have captured the tails of the distribution than you do at the end if you were just interested in the mean. So these formulas and the derivation are in that ISO standard that I mentioned, so you can get that or look at it in the library. So, all right. Typically, if I'm
Bruce, we lost your connection.
Yes, can you see me now? I'm back, I think.
Yes.
Great, thank you. So I'll just rewind myself for just a moment. So we've got, we know what we're going to measure, what we're going to scan, and we know who we're going to measure and how many. So if we're doing a major project, we would typically hire people to execute that.
Let's see, we seem to be having a bit of connection issues. The sentence ended beautifully, though. We had to choose people that we need to execute. There we go, Bruce, you're back.
Thank you. I might have a head scanning station, a body scanning station, heights from the floor, traditional measurement station. I might have a circumference station. So anyway, I'm going to divide my dimension list and my scanners into different stations. And the idea that would be that a survey participant would move from one station to another, just like an assembly line. So I need to figure out how many stations I'm going to have. I need to, if it's a large group, probably hire some backup personnel, especially if it's an extended data collection period. Part of the consideration in that is how long is that participant going to be there? Is that participant going to be there, 20 minutes, 2 hours? You need to think through all of those things. Oops, there it is. And critically important thing from my perspective is that each station has 2 people. One is the measurer and one is the recorder. And they are equally and equivalently trained so they can switch off throughout the day. So that minimizes fatigue and of course reduces observer error if you're less tired. And in training, I would, if I'm hiring, let's say 10 people for this project, during training, I would move them around. Maybe somebody, it turns out, is better at operating the scanner and somebody else is a whiz with a tape measure. And you want to put people in a station where they're at their best. But once you do that, then you get your measurer recorder paired together, and then they train together, and they continue their training until their observer error is where it needs to be. So in the training protocol, I would do an initial skill assessment. Let's have everybody try a tape measure and see how they do. Let's have everybody try to find some landmarks and see how they do, because I'll tell you, humans vary in many ways. That's why we do anthropometry. But among the ways they vary is their skill at various anthropometric tasks. We hired one guy one time, who's a super smart guy, great on computers, great at all kinds of stuff. I mean, he could not measure his way for anybody. He was terrible. So you need to put people through and put them in their best spot. And then you pair them. They practice together, and then practice, practice, and practice. And I would say also, when you're doing your practice, make sure you get some nice variety of body sizes and shapes. You don't want to just practice on people who are thin and beautiful because they're easier to measure. You want to practice on people who are a little bit more difficult as well. So all of that, and it's actually appropriate on my webinar here. Most of the time I've spent on planning, and that's exactly what you should do with your survey. Spend most of your time on planning, because if it's properly planned, it will go well. But once you're ready to go, I would do a trial run and verify the timing. Make sure, if you're going to tell potential participants, yes, this is a 1-hour project, you better make sure it's a 1-hour project. So you do your trial run with timing, you confirm your team error, you do your final equipment check. But I would also do a light schedule for the first few days, because measurers get faster as they go, but the first few days they're pretty slow. So we always emphasize real-time quality control while data collection is underway. So we like to use some software that identifies potential errors while the participant is still standing there, so we can remeasure if we need. We do also observer error monitoring throughout the survey. We'll tend, some small percentage of people will run through the process twice, and we'll, validate our measurements as we go. So now we've done our measuring. What do we do with data processing? If we're using scans and we're extracting dimensions, first step would be to extract those dimensions. Then we like to look at the data because we know from decades of experience that even the best measurers sometimes make mistakes. And so you want to find those mistakes and correct them before you build your database. We'll talk about that in a second. But then the final thing on data processing is to actually create your database. Traditional measurements are in a, array format, rows for participants and columns for dimensions. For your scans, you probably want to do a searchable scan catalog, depending on the kind of environment you're in. But how do we do that quality assurance on the data? I look at two things, essentially. I look at the extreme values to see if something's just too large or too small that it doesn't make sense. And I compare predicted versus measured values. I'll have an example of that for 1 second. But once we find a value we don't like, then we have to figure out what we're going to do with it, if we're going to correct it, replace it, or whatever. So let's take a look at this. So this is cervicality height over here and stature over here. These are highly correlated dimensions. So if I were looking at this, and if I were looking at the extreme values, I would see this guy up here who is kind of apart from the group and I might otherwise think, well, maybe that's a bad value. But since it falls so close to the regression line here, I'm going to conclude that that's a reasonable value because it's along that line. But let's suppose now, okay, let's suppose I had a value right here. So that is within my cervicality height minimum and maximum. It's kind of in the middle. So that would not appear as an unusual value looking at cervicality height alone. Similarly, it's kind of right in the middle of stature. It's not an unusual value with respect to stature, but when you look at those two together, that's an unusual value. That cervicality height is too high for that particular stature. So you would have to figure out, all right, is cervicality height wrong? Is stature wrong? Sometimes you can figure it out, sometimes you can't. But at least you would be looking at that value to say, something is wrong about that, so I need to take some action about it. Okay, so the traditional database I mentioned already, it's an array format. A scan catalog, should have some metadata in it so you can pull out people from different subgroups or whatever. Or maybe you can pull people out by shape. And so we're almost at the end, so we can do some questions. But so the base of the whole thing is complete documentation, which talks about your method, your sample, your staffing, your observer error, and so on. Typically, you have some summary statistics if it's a printed report. I'm going to erase my little mark here. Sometimes you want to do further statistical analysis with correlations or regression equations. And an important thing that doesn't happen very often is user guidance. And our friends over in CEN in Europe are doing a children's survey, and they are I've been very impressed. They're putting out not only a documentation of the survey itself, but a separate document about guidance for users. How should users use this data? Which is, I think, a terrific idea and should be done more frequently than it is. And then this is kind of a funny timeline. But so you would not ordinarily start all these things at the same time. So you would start your planning and design, and then your validation testing, maybe you start here, and your data collection, you start here, and your analysis, you start over here, but that wouldn't all fit on my slide that way. But anyway, those are the kind of things you would put on a timeline that helps you tell your customer when you're finally going to deliver the report to them. So the key takeaways for today, figure out what the purpose of your survey is because that drives everything else. Make sure you have standards and your measurements are validated so you get some comparable and reliable data. And then make sure that you've got careful sampling and staffing to make sure that it carries through and you get some good data at the end. You don't want to go to all that trouble and have lousy data. So that's it for me, but we have some time, about 10 minutes for questions. I'm going to stop my sharing. And I see, all right, there's somebody in the question already. Oh, this is a great question. Are there specific anthropometric measurements for people with disabilities? And does the ISO 7250 series cover this category? Second question first. No, they do not. Basically, the 7250 series is defined as applying to people who can assume an anthropometric standing posture. So if the participants cannot be in that posture, then you cannot use those definitions. There are folks at University at Buffalo in New York have a building design center, and they've done a lot of work with people with disabilities. And so they have, the author there is David Feathers. If you look up David Feathers online, his dissertation has to do with measuring people with disabilities, and he did a terrific job of validating his measurements. There are higher observer errors with that population because the participant posture is often more variable, but you can nevertheless do a good job. But back to ISO. ISO has not addressed that issue. Okay. Other questions?
Bruce, I have a question.
Okay.
You mentioned at the beginning the importance of the documentation of the landmarks definition
Yes.
and testing and validating the description and how the technicians are doing the interpretation of the landmarks. And you mentioned also the importance of training because in a large scale survey study is necessary to involve many measurers, and training measurers it's quite hard. My experience is that to locate landmarks in a good way, it requires years of practice. So training people that start working anthropometry from the beginning at first time, it's difficult to be consistent in a big group. So I'm trying to see the possibilities of the artificial intelligence networks to train, especially in 3D body scans landmarks, the possibility to train these locations. Do you think that this could be a future way of trying to be more consistent in the definition of the landmarks? I'm combining this with your idea of having a 3D avatar with the 3D positions. So, and defining an atlas of this. So, what is your opinion on around this?
You know, all I know about AI is that I should just invest a lot of money in it. But so I don't really know how it works, so I don't know. But I think it would be possible to conduct a test, and maybe AI is part of that. You'd have to feed it, as I understand AI, you have to feed it good information. So you'd have to feed it a lot of scans or bodies where you were sure the landmarks were in the correct place, as input data. Um, I think that would work. I mean, the other thing that you mentioned how hard it is to train humans, and I completely agree. A trick that I learned from Dr. Kochi in Japan, you have a person do the landmarking with invisible ink. And then you have the second person do the landmarking with a regular pen. And then you shine the black light on it and you can see how close they are together. So that's a way to test whether your landmarkers are doing the same thing. But in terms of the training, I think it just takes, as you say, years or at least a long time to get super, super good at it. And also train always with a variety of body shapes and sizes because we're not all the same. But the AI idea is intriguing. It's intriguing.
Yeah. What it can be interesting from the ISO or the standardization committees is to have a data set of with a ground truth to compare, and yeah, to have a data set that cannot be included in the training, and then we can compare if our results from our trained networks are good with this ground truth data set. So this is something that maybe the standardization committees that can offer in the future.
Well, that's a terrific idea. Where the ISO subcommittee on anthropometry is meeting this coming weekend. I will bring that up as an idea. I like the idea of a ground truth, that we all agree on, and then we can make our tools from there. That's a great idea. Awesome.
Okay. So we have another question in the chat.
Okay.
So this is a question for Gren Goodmeister. So the idea to integrate an avatar in the documentation is amazing. Could we think of a section in the avatar movements where the palpation of the right point for the landmark is shown?
I think so. Garrett, that's a terrific question, and yes, my skills are not in the avatar universe, but I have great confidence in the people that can do these things. I think that should absolutely be, maybe you could scroll your mouse over it some way, and if it hits the right spot, it glows or something. I don't know, but that makes a lot of sense to me. Great idea.
Okay. I have another questions related to the postures of gathering measurements, because one important difference, I think, between manual anthropometry and digital anthropometry is that in manual anthropometry, you can check and optimize the posture of the subject for each measurement. And with a scanner, we are only deriving the measurements from 4 postures that are the ones proposed by ISO standards. And some of the measurements in the manual protocols require a posture that is not exactly one of the four. So from that point of view, we are including bias in or differences in the way of measuring. And at the end, it's very difficult to have compatibility between manual measurements and scan measurements. So yeah, I'm not sure how to deal with this, and especially when we are including more applications in the project. The list of measurements from the ISO 7250 usually increase a lot, and then the number of postures also increase, and then it's difficult to match both things. I'm not sure if you have any suggestions to solve this.
I mean, it is a problem. You're absolutely right. It is a problem. I mean, I don't know that we can solve it. We could just make it a little better. I think the ISO scan postures are good ones, but I would say they're not the only ones. And so, I think the quickest thing, honestly, because scanning is so quick, the quickest thing is probably just to add some postures, add some, additional scans. And so, if you have three dimensions that you need an additional posture for, well, just, take another scan, seems like to me. Alternatively, if for whatever reason that's not possible, then I think you probably just have to know but the posture is different, so there is some bias. Likely the numbers are likely to be a little smaller or whatever it might be. I think
Okay.
full disclosure, if nothing else, full disclosure is the way to go.
Okay. So thank you very much, Ruth. So I have enjoyed a lot your presentation. It's the time, it's 6 o'clock, so we are going to leave here.